So hello and welcome to AWS Summit Berlin. And I hope you had some great sessions so far. My name is Konstantin Gonzalez. I'm a Principal Solutions Architect with AWS. And
my name is Elena Lesek, and I'm an Associate Solutions Architect with AWS.
Right. So today we're going to talk about prompt engineering best practices for large language models on Amazon Bedrock. So let's dive in. We are going to start by setting the scene a little bit. Then we are going to look at some useful techniques that Elena will then give you some examples for on how to apply to Anthropic Claude, which is one of our favorite models. We'll take a quick look beyond prompting, and finally we'll give you some resources that you can use when you start your own prompt engineering journey. So prompt engineering really is a bit of an art form. And to understand this, let's take a look at what a prompt really means. A prompt is the information you pass into a large language model to get some kind of response. So you write some text, which is the prompt, you put it into the large language model, and you get a response back. And this is a bit of an uncertain science so far, right? If we look at a traditional job like an engineer, engineers, they can depend on the rules of physics, so they always know what they're getting. Similarly, software engineers, as a software engineer, you can depend on some syntactical and semantic rules and everything is very precise. But as a prompt engineer, you're a bit more like an artist. You have to try out different things, find your way around, be creative, which is a good thing. So why am I saying that? Let's take a look at a simple example. If the prompt is what is 10 plus 10, you might get as a response 20 if you think this is a math problem. But you might also get something like 10 plus 10 is an addition problem. So this is more like a classification answer, right? Or you can get something like cuánto es 10 más 10, which is, it would be a translation use case. So one prompt, 3 different responses. There are other ways you can have fun with prompting. For example, in this case, we're instructing the model to, with the beginning phrase of, you are a high school physics teacher, answer questions in 1 sentence. And then we give it a question like, explain quantum entanglement. And we get something that makes sense from a point of view of a high school teacher. Quantum entanglement is a phenomenon in which 2 or more particles, yada, 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 that sort of thing. But if we start slightly differently by telling the model, you are an excited 3-year-old who ate a lot of sugar, answer questions in 1 sentence, and give it the same question, explain quantum entanglement, we get a very different response. Whoo, bash, bam, particles go zippy-zappy when they're together. And even if you take them really far apart, they still know what their friend is doing because they're magic connected. Same question, different answers. And the difference really comes down to prompt engineering. So instructions matter. And when you put together your own prompts, think about clarity and specificity. Here are 2 ways of prompting. One way is, tell me a story about cows. But there are so many ways you could tell a story about cows. Or you can be much more specific and clear. Tell me a story about cows. It should be roughly 2,000 words long and appropriate for 5th graders. It should be entertaining, but with a moral message about the value of loyalty. Make it amazing and memorable. So the key point here is, just like humans, LLMs cannot read your mind. As prompt engineers, it is our job to bring our mind into a text prompt that tells the model how to behave. So here are some useful techniques that you can use. One of the earliest discovered techniques is called one-shot prompting, which essentially boils down to giving the model an example of what you're looking for. For example, here, we want to generate airport codes out of text. So we might start with an example of what we are really looking for. And the example is, I want to fly from Los Angeles to Miami, provide the airport's code only. And we are already giving the expected results for this particular example, which is LAX and MIA for those 2 airport codes. And then we follow up with the actual question we want some answer for. I want to fly from Dallas to San Francisco. We start the assistance response with airport codes and square bracket. And now the model knows exactly what we're expecting. And it completes our sentence with DFW and SFO. So this is an example of one-shot prompting. We give the model one example and use that to illustrate what we are looking for so that the model is kind of guided into giving us the right kind of response we're looking for. You can also do few-shot prompting, and few-shot prompting is what you would expect. We give it multiple examples. For example, in this case, we want to use a large language model to classify tweets. We give it 3 different examples of 3 different classifications that we are looking for, and then the 4th one is the actual thing we wanted to do, where we are kind of pasting in some tweet, and then we get hopefully what we are looking for, because now we gave it some really good examples that tell the model what we want. You can also use a technique called chain of thought prompting. So with chain of thought prompting, we want to make sure that the model really puts some energy into thinking clearly. And we can actually do this really easily by telling it, let's think step by step. So on the left-hand side, you see an example where we're asking the model to solve a puzzle for us. A juggler can juggle 16 balls, half of the balls are golf balls and half of them are blue, blah, blah, blah. And we're getting a wrong answer because the model gets kind of confused, right? But when we are adding the simple sentence, let's think step by step, now we're getting a good answer out of the same model. This is a surprising trick that researchers found out in the early days of LLMs, and it still works. So think about when you're not getting the right results, simply ask it to think step by step, which is called chain of thought prompting. And now we can combine these 2 things. We can use examples and use that example to teach the model how to think step by step. So left-hand side again, an example that doesn't work. We are using Roger has 5 tennis balls. That's the first puzzle. And we're giving it the answer we want, like the answer is 11. But the model doesn't quite understand how to get to that answer, right? On the right-hand side, same example, but now in our example answer, we're guiding the model along our thinking process. For example, in this tennis ball example, the thinking process is Roger started with 5 balls, 2 cans of 3 tennis balls each is 6 tennis balls, 5 plus 6 equals 11. The answer is 11. So we're adding the thinking process, which is implicit chain of thought prompting. And now we can get, when we paste the actual question that we want some answer for, like the cafeteria had 23 apples and so on, now we're getting the right model output, including the thinking process, which also adds the capability for us to debug what the model was thinking. So it tells us how it arrived at the answer, and surprise, it gets to the right answer because it knows how to think. So when you craft examples, think about using examples where you're actually telling the model how exactly to think. So with those initial examples out of the way, let's get way more practical. And I'd like to introduce you to Elina, who is going to show you how to prompt Anthropic Claude, which is my personal favorite model here.
So, are you looking for some concrete examples of the best practices that we recommend in prompt engineering? This section will cover 9 best practices, and I would actually start with introducing myself. So my name is Elina Lasek, and I joined AWS 2 years ago. And, well, I wanted to follow my passion in scaling ideas as well as build machine learning products. I have had an honor to work with customers from different segments of different company sizes, and they all have had one question. That question was, what is that model that I should start experimenting with? In many cases, the answer was indeed Anthropic models. That is exactly why we have decided to bring concrete examples of prompt engineering with Anthropic Claude. I would like to start with introducing you to the latest edition of Anthropic Claude model family, namely Claude 3, with the corresponding API, namely Messages API. An important hint to prompt engineering is to think a step back and consider how the LLMs were trained. In the case of Claude, we have the alternating dialogue between user and assistant. That is built in the form of history of the conversation, which in this case would be messages. And that is an important hint for us to also consider once we are doing prompt engineering. So If you have previously used models slower than 3, then you would see something like completion API. And if you would like to use Claude 3 models, you would need to use messages API. And on the right-hand side right now, you can see the example of how the input into messages API can look like. And that is following this idea of the alternating dialogue between user and assistant that are given as roles within messages. And we also have something called system prompt that we will cover in several minutes in more detail. Now I would like to start with the best practice number 1, and you won't be surprised by it, because it is the tip on indeed being very clear and direct in our prompts. Claude definitely responds better to clear and direct instructions. At the same time, I'm personally still a big victim of using, this polite words like, could you please, Claude, can we consider, and similar things that are rather vague in case of prompt engineering. So it is helpful for me to always recall the principle of clarity here, as well as something that we could consider as rubber duck principle in software development, but in case of building LLMs, LLM applications, we can think about golden rule of clear prompting. The idea here is that once we are in doubt, we can go with our prompt to our friend or to our colleague and indeed ask them to follow something that we are pretty much prompting for. If they are able to follow, LLM is also likely to follow. On the right hand side of the slide, you can see our example. And well, if we are willing to have a haiku on a certain topic, and we would like to skip the preamble that is in the form of, well, here is this haiku, the idea would be to indeed be very clear in that and instruct the model to skip this preamble. So, having the clarity in mind, we would proceed. And do you recall Konstantin's example on the difference between explanations of quantum entanglement between PhD student and this overglucose kid? Well, the idea here is indeed to utilize roles, also known as role prompting, and it is helping us to give the context to Claude to understand what role it should inhibit. It won't be a big secret that LLMs are not the best ones when it comes to math. They generally don't calculate responses, they generate responses. At the same time, when we're using role prompting, we can help Claude to be more close to math world or the world of solving puzzles, thus improving accuracy. At the same time, how I'm thinking about role prompting is the sort of dress code. So if we are thinking about the party that we should join, we are checking what is the style that is expected there. Should it be casual? Should it be formal? That is also the concept that we can utilize here and think about this way of speaking to LLMs that can change the tone and potential style of the conversation that we will be going through. And on the right-hand side of the slide, you can see the example of the puzzle that without any additional role is likely to be solved in a wrong way. However, the simple trick of saying you are a master solver of all puzzles in the world can help to improve the accuracy. Konstantin has introduced us to the concept of few-shot prompting, and in context of anthropic models, how this can be put into action. Well, we can use examples. And we see that examples are indeed very effective. And generally speaking, it is also very helpful to consider examples that are coming from different edge cases. We know that the more examples, the better the response is, of course, with certain trade-offs that we can see when it comes to the number of tokens. And on the slide, you can see the example. And if our goal is indeed to get the concrete name and surname of the author of a certain passage without anything extra, we can pretty much prompt LLM to give us exactly this by using example. We have also thought about the concept of chain of thought and how to use it with Claude. And it works in a way that we can just give Claude time to think. if we would look into the example of the input that we are passing into LLM, we are using thinking as our XML tags, and we are letting the model to put chain of thought into action and consider this thinking step-by-step process within thinking steps. How the output looks like? Well, normally we would get the response from the assistant that would start with thinking and then with answer. And what is interesting is that exactly something that we would find within thinking XML tags is helpful for us to debug or to troubleshoot. You can already see here some peculiar feature of Claude models. What is it? Well, it is indeed using XML tags. And that is the tip number 5 that we would like to give. XML tags are helpful to structure the prompts that we are sending to LLMs. And once we would like to have certain sections within our prompts, that is where XML tags can help us to have the structure. If we would look into the example of us willing to have the email of, well, if we are the person that should ask our team to show up at some early time of the day as 6 a.m. and draft this email in some formal response, if we will just throw this into model in this form of, well, just show up at 6 a.m. because I say so, the model can sometimes misjudge and not understand that we are actually speaking about the email that we would like to send to our team, and it will start responding as if it was sent to it. And once we are introducing XML tags of, well, here is the context of the email, we can get the response that we were looking for. We can already see here that we are explicitly talking about the output that we are willing to see, and indeed we can help Claude with this output by speaking and pre-filling of our assistant for getting the output that we are expecting. How can it be done? Well, it is done very often in the form of pre-filling with an assistant. So a very common use case that we observe from our customers is some JSON files or some YAML files that are having certain structure, and we would like to get exactly files in this structure once we are getting the response from LLMs. And we are here in the example pre-filling for JSON files just by using a first curly bracket, which is of course increasing the likelihood of us getting JSON file as the response. Another very peculiar feature of Claude models is big context base of 200,000 tokens. We would really encourage you to use this context base efficiently. Because, well, what is 200,000 tokens? It can be a book. It can be a book that we will just pass to LLM directly. And to utilize this way of using context base effectively, what we recommend is again to consider XML tags to separate what we are passing and instructions. We would also think about using quotes for us to have the response that is closer to the content that we are passing, as well as, well, as it also works with us as humans, we can prompt for Claude to read the document carefully because it will be asked questions later. And the last but not the least tip here is again to reconsider future prompting and to use the questions and answer pairs in the form of examples. When it comes to the prompts that are having certain steps in between, what is also helpful is to consider prompt chaining. I will jump straight into the example. So if we would be having the task of extracting the names from certain text, and we would like to have them in alphabetical order, we can definitely start with saying, well, just extract those names in alphabetical order, or we can consider splitting this into 2 prompts, so that in the first one we would have the extraction of names first, and in the second prompt we would have them alphabetized. With this way of chaining prompts, we are increasing the likelihood of getting the output that we are looking for, and you can also recall here the example of pre-filling the assistant with this names XML tag. So the last but not the least tip from us today would be on using structured prompt templates. If we are considering the example was this long document that can be, as I mentioned, books, it is very helpful to put this input data before our instruction. If we are looking into a different example of using certain input data that is having the effect of iteration or certain dictionary or list, and in this case, in the example, it would be the types of different animals. The idea here would be to also structure our prompt in a way that we would have the iteration within this input data, and thus our output would be having also different types of animals put into it. So we have started talking here about some structures that we are giving to our prompts, and now we would like to cover something different. We would like to cover system prompts. So those prompts that are going into LLM as initial ones. Those ones that are setting the scene for the conversation. You have already seen different bits and pieces of them within our previous best practices. At the same time, now we would like to bring them all together into one system prompt template, so to say. You will see 9 sections here, and again, you can definitely avoid using some of them if that doesn't fit your use case. At the same time, what we strongly recommend here is for you to follow the order that we are having here. I will jump straight into the example of how this system prompt can be built, and our use case would be to have a certain career coach that would be helping users with their career aspirations. So we start with the element of our system prompt template, which is in giving the role. So here, the first things first, we are explicitly saying that you will be acting as an AI career coach with certain name, and we would probably like to maintain the same name for this career coach during our conversation. And at the same time, what is your goal? Your goal is to give career advice to users. The second element would be here to use certain tone context or style of the conversation. So you should maintain a friendly customer service tone. The third tip is utilizing the context base and is passing certain background data for our career coach to process. And again, it can be included within XML tags of, in this case, guide. The next element would be to give more detailed task description as well as certain rules. And here you can also pay attention to how we are letting Claude say that, well, if you don't know, you can tell that, as well as if someone is asking something that is not relevant to the topic, you can also say that, well, I am here only to give career advice. The next step would be to use examples on potential, also common cases as well as edge cases, as well as give some immediate data. In this case, it can be probably the history of the conversation or, for example, the information of the profile of the user that our career coach is talking to. The seventh step would be to indeed reiterate on what is the immediate task here and allow Claude or another LLM of your choice to think step by step and even take a deep breath, because we've heard it to work efficiently from scientific papers. The last but not the least element here would be to set certain output. And again, we are utilizing XML tags here. And that has been the suggested elements of our system prompt template. Let me bring them all together for you. And that would be the overview. And I see that some of you are willing to take the picture. So now we are having the system prompt template. How can we move even further? And how can we get even more professional? And consider what can be done after we have gone through prompting. Well, we do consider prompt engineering to be an art form. At the same time, with Konstantin, we have decided to try to add science to this art form, and with simple steps, help to make art work for your use cases. So the first step would normally in our journey would be to, of course, understand the use case, as well as develop certain test cases. I live in Munich, so I will walk you through the example that would be helping me with understanding Bavarian culture, or it can be also the culture of Baden-Württemberg. So let's think about this use case and develop the test use case that, well, maybe I will be asking about certain dishes that are relevant to a certain area of Germany. Thus, my preliminary prompt would be on cooking a certain dish. So how do I make Käsespätzle? Or how do I cook Oberster? And of course, afterwards, I'm going into the iterative phases with evaluations. That would be then going into loops. In this case, the first loop would be, for example, to consider adding the role, such as, well, you are an experienced ethnographer or you're an experienced cook. And thus we will be refining the prompt. That will be coming to the point of being polished to the extent that it fulfills our goals. A tricky part here is indeed in setting evaluations. And if we have some test cases that are closed-ended questions, having yes or no answer, it is possible to evaluate that with not many issues. But if it is open-ended question, let's again look into the example of Käsespätzle. And if we would have again this first prompt of how do I make Käsespätzle, we would get, of course, LM response that would be telling us what elements and what ingredients we would have in our dish. What is interesting here is that we can utilize rubrics and define what we would like to include in the response for it to be evaluated as positive or negative. So I would prefer to have certain ingredients, and once we have the response that fulfills the criteria, we would have the positive result. And we would be knowing that, well, our prompt engineering and LM response were indeed true for us. Many customers come to us and ask about what can be done for reducing hallucinations. And that is also something that we would like to encourage you to do with dealing with hallucinations. And what can be done is indeed to give LLMs permission to say, I don't know, as well as answer only if it is very confident in its response. It is also possible to ask about relevant quotes from the context that we have passed. And once our context is growing, once we are having certain iterations and changes to the context that we would still like to pass to an LLM, we can consider using something called retrieval augmented generation. Retrieval augmented generation would look in a certain way that instead of having the typical flow of user asking the question from the LLM and getting the response, we would be also passing a certain additional context that would be in the form of dynamically changing knowledge bases or certain internal sources. We can consider product descriptions, we can consider FAQ pages, and in this way the flow would be changing in a way that all the documents would be passed into some vector database, and once the user is sending the question, we first get everything relevant from the context. Let's say 3 pieces of certain FAQ description, and then that would be passed as the context together with the question to LLM, thus creating the answer for us. And well, there are different moving blocks in this architecture. So, Konstantin, shall we help the audience to consider different tools for building retrieval augmented generation?
Sure. Thank you, Elina. So I like to think of retrieval augmented generation similar to giving the LLM a cheat sheet, right? So as you know from school, probably when you don't know the answer, you tend to make up something But if you have a cheat sheet, it's very easy to solve the question. So what we're really doing here is we're using the knowledge base and some way of searching the knowledge base, like a vector database or search engine or anything you can use to provide the relevant information. And then we generate a cheat sheet that we inject into the prompt as part of the context, so that increases the likelihood of the LLM giving the right answer, because now it has all the data it needs. You can set up this thing on your own by putting together the components like the knowledge base and setting up the orchestration on all that. That is fun, but it also can become old quickly, especially when your manager is breathing down your neck and say, hey, when is my solution ready, right? So our job at AWS is to make it easy for you. So first, a while ago, we introduced Amazon Bedrock, which makes it super easy to use a selection of different LLMs with an easy-to-use API in a secure way, so that you stay in control with your data. And then we added an additional feature called Knowledge Bases for Amazon Bedrock, which essentially gives you the retrieval augmented generation architecture that we looked at before as a ready-to-use feature of Bedrock. So all you need to do is you bring your knowledge base in the form of some sort of document. You can import them into knowledge bases for Amazon Bedrock. You can choose which of the vector search engines or databases you would like to use from a collection of choices. You can choose which LLM you want to use as part of your architecture, and then Bedrock does everything else automatically for you, including the prompt engineering bit. If you want to control the prompt, you can actually add your own variation of the prompt, or you can simply use what is shipped inside Amazon Bedrock. So Bedrock and knowledge bases make it really easy for you to build your own knowledge base architecture, or your own retrieval augmented generation. And retrieval augmented generation is one of the most popular use cases we see with customers, because it generates immediate value for your business. No more searching and hunting through long product manuals, long boring documentation. You can simply ask questions, get relevant answers that are right from your documentation, including citations, so that you know that you're getting good answers here. Another thing that our customers like to use with LLMs is called agents. So agents and function calling. How does it work? Well, instead of just injecting documents from a search engine like with retrieval augmented generation, you can go one step further and you can tell the model, hey, model, Claude in this case, right? You actually have access to some tools. Let me explain you how those tools work. And then you're giving it like a prompt engineered version of an API specification. So what you're doing here is you're telling the model you have access to a weather service, you have access to a Wikipedia, you have access to some other tool that you choose how it works. And then Claude does not really call those tools on its own, but it will tell you, hey, I would like to use the weather service now with these parameters. And then you can engineer, or you can set up the actual function call, do the operation, and give the result back as part of the prompt. So how does it work? Well, first of all, you start by putting together a prompt where you describe to the model, here are the tools you have access to. Think of this as you put together your answer. You put them into Claude as part of the prompt. Claude now decides whether it can answer the question right away, or whether it would like to use one of these functions that you gave it. And in the case of no, it will probably answer with some definitive answer, like, I don't know. Or it says, okay, I want to use those tools, and Claude will actually output the function call in the specification that you told it. So if you told it that please use XML calls that are called function calls, invoke with the parameters here and there, it'll give you the kind of XML that you expect, and now you can go and execute that. So the execution step looks like this in more detail, right? So you get this function call XML from Claude as a response. You know, you can actually grab, or you can detect this with your traditional code, like a Lambda function. Hey, Claude wants to call something. You can use this XML, maybe validate it, and then you actually implement your own client in your own code. Could be Lambda, could be a container, whatever, that does the function call. In this example, it would call the weather function. And then you inject the results back into their own XML text, like function results. And then you send the whole thing back to Claude, right? The system prompt, the user question, the function call, the function results, and then you let Claude decide what to do next. And then Claude sees, oh, I have everything I know, I want, I have the weather data, I can now give a great answer, and then you get your answer. So that's how you implement your own functions in the context of a large language model, by telling the model these are the functions you can use, giving it an API specification in an easy-to-use language such as XML tags, and then you let the model decide when to use which tool. You are in control in how you implement those function calls, and then you give everything back for the model to process and give a definitive answer. Now, when you implement something like this, explain the function capabilities in great detail, right? This is the same as explaining to a human like your colleague, how does this API work? You can also provide a diverse set of examples. Here is an example of using this call to do X. Here is an example of how the parameters might look like for Y and everything. And you can actually use the stop tag or the end tag of your function specification, a stop sequence, which tells the Bedrock service, okay, stop after this sequence here, after this XML tag here, because now the XML part is over and you have a definitive stop condition. And if you're not getting reliable results, think about the prompt chaining tip in the beginning. Don't make your tasks too complicated. Break them down into simple function calls and then do them one by one. So here's an example on how it looks in practice. This is how you would describe the tool description. Tool name is getWeather. This is the description. These are the parameters, location, which is a string. You can actually add type declarations there as well, and all that stuff. And you can use that as part of your system prompt. Again, you can do this all on your own, and it's fun the first time. But you can also use a feature called Agents for Amazon Bedrock, which allow you to either programmatically set up these functions with your own function code in Lambda functions, or you can actually go through the console and click together your own chatbot using functions, and thereby reduce the development time and the time to results to just a day or so, instead of weeks of trying out and figuring out stuff and prompt engineering and everything else. Lastly, let's take a look at a different problem. What to do with malicious users who want to inject something into the prompt to get it to do something that you don't want to. What if you have some bad user behavior that you want to mitigate against? The good news is that Anthropic Claude is already very resistant to jailbreaks and other bad behavior, which is one reason why at Amazon we like to partner very much with Anthropic, because they focus a lot on responsible use of AI. But again, you can also get one step further by adding a harmless screen to evaluate the appropriateness of the input prompt or the results, right? Think of this like a firewall that you're putting in front of the LLM that checks whether input or output are really compliant to your own company rules. And if a harmful prompt is detected, you can filter it out based on that example. Surprise, you can use a different LLM or another LLM to do that screen for you. So here's how a prompt might look like for a harmless screen. A human user would like you to continue a piece of content. Here is the content so far. If the content refers to harmful, pornographic, or illegal activities, reply with Y. So you're essentially using an LLM as a classifier to classify whether this is a malicious prompt or not. And then you can use that to filter it out. Again, you can do it on your own, or you can use a feature from Amazon Bedrock called Guardrails for Amazon Bedrock that lets you set up those guardrails either from predefined rules or from your own rules that you bring into your application. So we hope this was useful to you. We hope you learned a lot. No need to take so many photos. You can actually go to our helpful prompting resources page that we prepared for you. Maybe take one more photo from this QR code here, and that'll guide you to a page that we prepared for you with a white paper, with some prompting resources, some links to useful documentation, and even a workshop that you can use to try out some things and learn in your own pace and build your own applications. So with that, thank you very much for coming and enjoy the evening of the summit.
Thank you.